Okay, in this problem, we are trying to find the reactions given numbers for everything. So let's go ahead and get started. So I will start by free body diagram. We'll start with just basic statics. Got A and B, like so. I also have a moment at A that I need to figure out. Okay, so then I'll sum the forces in the y direction. Okay, and I've got A plus B minus 9,000. We'll flip that to newtons. Call that, set that equal to 0. Then I will sum the moments about that cut point. I'm sorry, the fixed point A. I have that moment at A, given right there. Then I have 5 times B, because again L is 5, so plus 5 times B, okay? And then I have negative 10 times the 9,000. Okay, so cleaning these guys up a little bit, I'm going to get two equations. I'm going to get A plus B equals 9,000, and I'm going to get the moment at A plus 5B equals 90,000. Okay, so I have two equations but three unknowns. Okay, which means I need to figure some stuff out. Okay, make cut. Okay, so what I'll do here is I'm going to make this cut right here. I'm going to call this X, moving in that direction, and we'll see where this takes us. Okay, so I make that cut. Okay, and I've got A over here. I've got my reaction moment MA, and then I've got V, I've got M, okay, and again this is being done at some arbitrary X, which is again from point A. So taking the moment about the cut point, okay, I've got my moment that I'm trying to find, M, okay, I've got the other moment, MA, okay, and I've got negative A times X. Solving this for my moment that I'm trying to figure out, and I get M equals AX minus MA, that reaction at MA. So then what I'm going to do is I'm going to use my second derivative equation of the deflection. So d squared V over dx squared equals AX1 minus M sub A. Integral 1, go to the slope, dv dx, and I get a x squared all over 2 minus ma times x plus c1. Integrate one more time to get to the deflection, and I get a x cubed over 6 minus ma x squared over 2 plus c1x plus c2. Now I'm going to start using some deflection equation, what I know. So what I know right off the bat is that at A, okay, so when x equals 0, I know two things. First thing I know is that, well, either one. I know that v equals 0, right? There is no deflection at point A. When x equals 0, v equals 0. So from that, I'm going to use that first equation. I get 0 equals 0 minus 0 plus 0 plus c2. So from that, I learned that c2 equals 0, which is a good thing. The other thing that I know is that at point A, where x equals 0, so when x equals 0, the slope also has to equal 0 because, again, I'm rigidly fixed there. So the slope is perfectly horizontal at that point. So the slope has to be 0. So dv dx equals 0. So I go up one equation. I say, okay, 0 equals 0 minus 0 plus c1. And from that, I learned that c1 also equals 0. So all this stuff goes to 0 like that. Now I know one more thing, which is that at point B, the deflection also has to be 0, because again, I'm at a pin there, so there is no deflection there. So when x equals L, which of course is 5 in our case, then the deflection equals 0. So going back to that deflection equation, I say 0 equals, a times 5 cubed all over 6 minus ma 5 squared over 2. Okay? So from this, I can solve for a in terms of ma. So from this, I learned that a equals 3/5 ma. And what that gives me is it gives me a third equation, right? So now knowing this, I can plug this guy. Where can I plug? Let's see here. Right? So now I have a relationship between I've got 3 equations, 3 unknowns. So this is my third equation, essentially, right here. And I'm just trying to see exactly what I did here. So, all right, so I go up here. This is what I did. I said, okay, so now I know that B, taking that first equation, equals 9,000 minus 3/5 times ma, like so. Okay. Now that I know that, I can plug that into the next equation, which is ma plus 5 times 9,000 minus 3/5 ma equals 90,000. Okay, so now I can solve for ma. I find that ma equals negative 22.5 Newton meters. Plug that in up here, I can find B. B then becomes 22.5 newtons. And then I can come down here and I can say, okay, then A becomes negative 13.5. So what that means is, again, I have the reaction at A going upward. It's actually downward. That's all that negative sign means. Okay. But again, all we do on this is we try to do statics, get 2 equations, 3 unknowns, a statically indeterminate. Then we do what we know about deflection using the moment, couple of integrals, right? And then those boundary conditions to help me get a third equation that I can use to finish solving the statically indeterminate problem.